Atana Limited offers a range of organic, sustainable, biodegradable coagulants called Cofloc, which are a viable alternative to traditional inorganic iron or aluminium-based metal salt coagulants. A jar test can be used to compare the effectiveness of the aqueous solid phase separation using Cofloc and ferric sulphate. In order for the coagulants to work properly, the wastewater should have a pH of around 7. Cofloc can work between 4.5 and 9, whereas ferric sulphate works between 6 and 8. Coagulation is a process that alters the surface charge on dispersed colloidal particles in a liquid so that they are able to agglomerate. The first stage in floc formation, the solid phase. Flocculation is the agglomeration of coagulated particles to form a floc, visible solid phase distinct from the aqueous phase, which can settle or float, awaiting mechanical removal. When metal ions are introduced into an aqueous solution, hydroxides are precipitated. Cofloc does not introduce metal ions or require as much pH correction, using sodium hydroxide as metal salt coagulants. Therefore, no hydroxides are precipitated. This means that the volume of the solid phase separated from the wastewater during treatment is not increased with solids resulting from the chemicals used within the treatment process itself. This can be seen in the amount of solid phase, or sludge, seen when comparing beaker A that has been treated with Cofloc and beaker B that has been treated with ferric sulphate. Cofloc generates around 30% less solids than metal salt coagulants. During the clarification process, either settlement or flotation, the Cofloc-dosed solid phase continues to dewater and consolidate, further reducing the volume of sludge to be disposed of. This is not so with the metal salt-dosed sludge, as it traps water within the solid phase and would require additional mechanical processing to dewater further.